This week we are following the patterns of each of the reactions that we've established, and so far we've covered double and single replacement reactions. Both of them have a special tool, which is why we started with that. Now today we're going to do the rest of them, which are pretty straightforward and just kind of a matter of writing from the name that's given and following the pattern. The only extra little piece of information that we're going to add today is state of matter for common elements and compounds that we will want to list in our equations. So our three reactions that are left are decomposition and synthesis, which are the kind of opposite of each other. Decomposition is breaking down into elements. Synthesis is forming a compound from its elements. And then combustion, burning with oxygen to form carbon dioxide and water. So our states of matter that we'll typically see, I'm actually going to start with gas. The gases of the elements on the periodic table, the ones that are gases are most of our diatomic, 7. So if you remember those 7 diatomic elements, you should be able to remember states of matter. So you got hydrogen, oxygen, fluorine, see, my pen is not working. There we go. Okay. And then nitrogen and chlorine. So those are the 5 that are gases, and then all of the noble gas group. See if I can move this over. There we go. All the noble gases. So that would be group 18, helium, xenon, all of group 18 gases. Then elements that are liquids, there's only 2. Mercury and bromine. And then that leaves really only one of the diatomics left because there are 7 and there's only 6 written here. So our only diatomic solid is iodine, and then all the other elements are solids, which includes all of the metals, and then all the remaining nonmetals. So those are our elements. Most of them are solid, with a few, a couple liquids and a handful of gases. For compounds, again, we're going to start with gases. Common compounds, you're probably already going to know these as I list them off. Carbon dioxide is a common gas that we're going to see it in combustion reactions, so you can label that as a gas. And then all hydrocarbons, kind of like that CH combo, those are going to be gases. And then another one that's a gas is ammonia, NH3, or nitrogen trihydride, if you're using the binary naming system. Common liquid, really the only one that we're going to focus on here is water. So you can always label water as a liquid unless it is being heated in a reaction. If that's the case, then water is a gas because it has been vaporized by the heat. So water is gas if heated. Just make a little note of that. Therefore, in a combustion reaction, you would label it with a G because combustion is burning, which involves heat. Ionic compounds are always solids. And then, of course, like we talked about with double and single replacement, we want to check the solubility rules to decide if it's solid because it's insoluble in water or if it's aqueous because it's dissolved. So that's the only caveat here. Check solubility rules for double replacement. and single replacement. All right, so that will help us in writing our equations. Whenever you write an equation, always include state of matter next to each substance. So for each of these, we're going to classify the reaction, then write and balance their chemical equations, and we're only focusing this time on synthesis, decomposition, and combustion. You won't have any single or double replacement. We covered those in depth on Monday and Tuesday. So our first one says calcium oxide is formed from its elements. The formation of the compound is synthesis. We know that calcium oxide is going to be our product. And then it's from its elements. So we have calcium and oxygen. Make sure you have the O2 because oxygen is diatomic in its element state. So there's our equation. CaO is the correct chemical formula. If you need to check the charges and do your crisscross method, this would be a 1-to-1 ratio to CaO. Okay, so there's our equation. Now we need to write the states of matter. So calcium falls in that all others category. So this is a solid. Oxygen we listed with the gases, and calcium oxide is a compound, ionic compound, so it would be a solid as well. So there's our equation. Last thing we need to do is balance it. So we've got 2 oxygens on the reactant side, put a 2 here, and that will balance out our oxygens, but it imbalances our calcium, so we add a 2 here, and we have our equation. Ta-da! So a couple of steps to keep in mind. Classify it, write down all of your components of the reaction, determine their states of matter, then balance it. Magnesium nitrate breaks down into its elements. So this is kind of the opposite, decomposition. Magnesium and nitrogen. Now check your charges to see what our formula should be. Crisscross method, this should be Mg3N2. So we're going to break it down into magnesium and nitrogen, because those are the 2 elements in this compound. If you were thinking, why didn't you write N2? Because nitrogen's diatomic. Good job. And if you didn't catch it, try to remember for next time, anytime you have one of those diatomic 7 as an element, it has to have the 2. Now let's put in our states of matter. Magnesium nitrate is an ionic compound. Magnesium is a solid. Nitrogen, here's one of our gases we listed. And then we just have to balance by putting a 3 here. Ta-da! And we'll do one more, and then I'll leave the rest of page 12 for you to complete. Propane gas combusts. So propane is C3H8. We know the combustion pattern is always the same here. So let's classify that as combustion. Now we can put in our gases. Everything in a combustion reaction is a gas. And sometimes we'll put a triangle here to show that there's heat. You really could do that for synthesis and decomposition as well. The little delta just means there's a change in energy that causes the reaction to occur. So we usually have that for synthesis, decomposition, and combustion, but it's not really part of synthesis, single replacement or double replacement, since those are occurring in water and it has to do with their ions swapping places. So that's why we're kind of splitting them into 2 different realms of thought, because they're a little bit different in their mechanism for the reaction. So the little triangle, I won't count off if you don't have it, but just a little tidbit if you ever see it. It's just telling that you're adding some energy in the change, whether that's in the form of a flame or heat or even a catalyst, like we saw in lab a couple weeks ago. So last thing we need to do here is balance. Combustion, we always start with carbon and hydrogen. So I'll balance my carbon and hydrogen. And now I have 10 oxygens. This one ends up nicely working out. We don't have to double our coefficients. So there's our propane combustion. You've got a few more problems to do on page 12 for our synthesis, decomposition, and combustion reactions. Always add that state of matter based on the table we wrote here.